and I'll do the introduction. Okay. All right, the meeting's being recorded. And so, in the interest of time, though, let's get started. Well, welcome to the last two exciting lectures in our spring 2022 MassStat Colloquium series. I think we've had some truly wonderful speakers. I'd like to thank all the speakers for fantastic presentations. And we finish with two really fine lectures. So today we have our own Kateryna Nesvit, and I'll introduce her in a bit here. But on Thursday, and it is going to be simul-linked, Nimai and Yang are going to give a lecture in which we acknowledge the invisible hand in economics, which sounds mystical and sounds like a wonderful lecture, and its response to the lecture of Gail Gaillard earlier in the semester. And it's always wonderful to have a debate. But today, we're extremely fortunate to have Kateryna talk. Kateryna was supposed to talk back in March, and a little something happened. Her hometown's Kharkiv, and it's a wonderful university town. And it was, as we know, invaded. And it's still, unfortunately, an ongoing battle. But Kateryna and I talked, and she was actually able to say that today would be a good day to give the talk. Now, she has a rather impressive background. She started her path in mathematics in a mathematical family, and she wrote her first article at age 18. And she completed her PhD in mathematical simulation and methods of calculation at age 25. Fantastic, what a start. And she was working in Kharkiv. She has 15 years of experience in scientific research writing, and in that time period been incredibly productive, 65 published papers, and she has a patent, which is also a fantastic thing, tricky to get, and I know that, and Michael Robinson knows that well. And she's had research funded internationally, Germany, Italy, Sweden, and here in the States. She has 11 years teaching experiences, teaching classes such as numerical analysis, algorithms for data science. Sounds like right up my alley. We should talk about tools of scientific computing, knowledge of graph and data modeling. Again, another thing I'm strongly interested, and artificial intelligence. And we all need some artificial intelligence to make up for, we all need more intelligence. She's also built mathematical models for a variety of things. And when she came to the States, she developed an expertise in data science. And that's what her talk is on today. So with that, I turn the floor over to Kateryna, and I'd like to welcome her to our colloquium series. Kateryna, the floor is yours.
Thank you so much, Steve, for the impressive introduction. And I also would like to first say I'm very grateful to Marie Gray, to Artur, to Mikhail Baron, to Jeffrey, to everyone who supported me during this time. It was difficult time during the last months, and your support and your welcome to department was given me the strength that I can talk now, and I can present what I was doing before, and I hope I will continue my path and continue to what I would like in numerical methods. So once more again, my greatest support and very appreciated professional assistance and support to chair of departments, Artur Elzy, and newcoming chair of department, Mikhail Baron, and all the faculty members. Thank you so much for all your support. I will share my screen and start the presentation. Do you all see my screen okay? I have a pointer. First I would like to start with that I attended the conference on computing and data science as well. I like exchange their experience with colleagues at San Diego Supercomputer Center, Scripps Institution of Oceanography, San Diego State University, Ohio University, the current Institute of Mathematics. I very love their Neo4j technology and work with Graph and attend a lot of open data science conference. And the whole reason behind all of this is we have so much information around us and we don't have enough time. So the software knows how to obtain the necessary numerical results. And the modern computer does this process faster. But the only person's experience through this knowledge can apply the input data correctly. Also, each real life problem should be solved timely, efficiently, and the solution should be available for existing computer software and suitable for actual use. And of course, the accuracy of the solution should be consistent. That's why it's so important to apply our skills to the problems that are waiting to be solved. And here I put a couple of projects that I was working for, and I will explain a little bit more about each of them today. And the first I would like to start with fractal antennas. Fractal antennas are used in a variety of modern mobile devices. As you can see here, the mobile phone. And my PhD was focusing on developing the mathematical models and especially compare between the existing model, which based on the logarithmic singularity, their integrals with singularity in denominator here, and especially hypersingular integral equations when we have a power of 2 over here. And these mobile devices and their compact size, especially with fractal technologies, they make a more essential piece of their wireless communication, Bluetooth, Wi-Fi, and GSM standards. That's why this topic was very important for me to explore, to find the best solution, to find their more suitable way to calculate. We know there are background of it that the electromagnetic waves comes and we have the incident wave. We have there two cases which comes from TM case when there is no magnetic field, or it's TA case when there is no electric field coming. So there is a propagation wave that is coming to our structure. During my research, I explored different precursor structures, started with dielectric, without dielectric, with different kind of strips. I explored and discovered their tendency, what is happening with the power of that antenna if we would fill some dielectric in, and with their width and height. So I did a lot of comparison reason between their different structures and different mathematical models, as you can see here. And my main focus were on their hypersingular integral equations because it's unique. I can say it's just a couple of very good professors I found over the world who I was able to speak with and come to their conference in Czech in Mathematical Institute to spoke and exchange the solutions to prove that. And it's with the end, when I compare result, it was very very efficient, comparable to existing solutions. So while I was exploring different type of the mathematical models, I came up with some patterns where some problems that have similar mathematical models. Some of them has or not additional logarithmic kernel, and based on all patterns and discoveries that I made, I use the different integral operators for the hypersingular, singular integral operator, and the operator with logarithmic singularities. As known, any mathematical model which is built, and here you can see the B, it defines the impedance of the strips material. So I also explored, oh, by some reason I skipped this slide. So it's a table that helps to understand how I capture all this pattern, because here you can clearly see that the mathematical model based on the singular equations in the world right now, it almost everywhere exists the mathematical models. They just need compute and have a discrete model. But for the hypersingular integral equations, there is no mathematical model were available. That's why I was building that. And here there are different type of their works with boundary and periodic structures that I was working, and based on this picture, so it becomes more clear with which conclusion I came. And moving from the mathematical model to the discrete model, so that I use the discretization for it in order to solve it. It was a very big system, I would say, and time consuming. But then I started to do their numerical experiments, and the numerical experience shows exactly where their fractal structure and precounter set is making the essential work. So the propagation in specific direction are more better than in other directions. So we can locate antenna actually, and the other things, when I explore the material from which antenna should be, we can see that some materials have more better values than others. And I started to use the Constantan. Constantan, it's a specific material that right now are using in two biggest companies in Spain and here in the United States in Boston. The company calls Fractal, and they produce these antennas, and it's much more efficient than other materials of the strips. Based on the different level of the fractal geometry, here you can see I compared with the first, second, third, etc. So I increased the gaps and the slits. So I made this whole variety of investigation in order to conclude that mathematical models based on the hypersingular integral equations and numerical results for the diffraction problems, and especially on the prefractal plane parallel structure, this model were created and computed in 5 times faster and then based on the singular integral equations. The comparing obtained results were analyzed with existing software. So I made the comparison to make think that it's true, it's valuable, and it does the same. But it's more customized, its own program, and it computes faster. This research I made with my scientific supervisor, Professor Gandel from Karazin Kharkiv National University. The other thing I was working is making the 3D model. This 3D model research focuses on creating computing models and has been funded and produced by the company Orthopac during the, unfortunately, another war in Ukraine. In 2014, in Ukraine, the first war started, and a lot of soldiers were needed treatment. And in Kharkiv, we have a very big, good university for the spine treatment, for their any treatment in I'm sorry for my throat. We have a Joint Pathology Institute, and for which I cooperated, and we developed in cooperation the 3D model that helps the soldiers to have more quicker recovery. And the company actually produced that model with construction. I calculated the all stress strain loading, what will happen for each case of the situation. And this research I worked under the supervisor of the Professor Popso-Shapka in Setenko Institute of Spine and Joint Pathology in Ukraine. This 3D modeling inspired me to compute not only numbers, but in medicine, other things that can help. So another thing that I was working on is computing in implantology. And this 3D model of the implants in the dental system was developed to calculate the efficient parameters in the biomedical system. This research were performed in cooperation with Department of Stomatology, first faculty of the medicine in Charles University in Prague, General University Hospital in Prague. So we did a lot of different constraints on their implants. Until now, our articles still on demand, and we continue in that direction. So it's very valuable, and I'm glad I was a part of it. Next thing, it's a little bit different, but here is a very tricky words. Which sounds simple. It's similarity and recommendation. What is the similarity? Which parameters could determine it more close? And what is different between prediction and recommendation? Because we so often hear these words. There is a lot of choices every day around us, and it becomes really annoying to waste our time just trying to find the relevant information, the books, papers, news, films, and so on. So recommendation system help us in this complicated way because we also wish to get the right information immediately and without any asked questions. It means we should read the user's thoughts. How we can do this? How we can help user to take the right decision. The key idea of recommendation is simple and just choose some similar items to users and recommend it. So after I finished my PhD and I worked on the hard mathematics with integral equations, I tried myself to help more people and build something powerful that can get an impact. I worked as a data scientist and I built my first spool app, which has created the personal fit, where is content for photo and video. The size of the ball over here is representing how much you like it. There is also a list of recommendations for top creators, top givers, popular stories, trending, and a couple of good features. It's we can like the content, but also the app gives you ability to create and be rewarded for that. So be rewarded, it's kudos, and someone else can give you kudos. There is 2 links you can explore after I share the presentation. The app is available in Apple Store, and there is a website. But words is good. I think it would be interesting for you to see how it actually works. So I would like to mirror my screen and show the app. Here how it looks. And you can move the balls. So each ball is movable, and it's actual like story. There is a profile, and I will share, for example, my stories at the beginning. So it can be a photo which can contain likes.
Hello, smile. Everything will be okay.
It can be a video, it can be books that can be rewarded, and you can see their sign below as a dollar sign, so it has the kudos. It can be a video, which you can see that the number of likes can be given more than just views. This is our city, Kharkiv. A little bit more about my city. This is our bridge, how it was looking before. And there are other things that for this app is important, that it's the content that builds exactly personalized for you. This is a train station in Kharkiv and our fountain, so you can see a little bit about from where I am. And this is our main important the thing in Kharkiv. So if you went through this arc, then you will be happier. So everyone would like to come here. This is our park just next to the university where I was working. And just near the park, we have the biggest square in Europe that is containing a lot of new events. And behind of it, you can see their university. So this is actually the Kharkiv National University that is. And what I would like to show the prediction and the stories. So you can see the bubbles, and the bubbles represent the size, how much I like it. So for example, I created another account, and you see Atomic Habits. So it's another account where we can give likes. It can be more per the one book. We can give some kudos for it, and then it will become the more biggest size. So I will stop showing this app. This is about the spool. The first app I was building. The second app, I was working as the vice president of the data science, and the second app is Comp Edge app, which is predict the compensation for employers. Interesting question, and it should be personalized. And there is a lot of things in data and gaps, so it was challenging to work with this data. But I'm really happy that I was able to stop a little bit my teaching career in order to dive into details and fix this problem. Based on my algorithm and their whole system that I created, we submitted the scientific pattern together with our CIO, Richard Lear, and the Timothy Skaggs, our vice president of their software engineering, and a lot of good people in our team members. And I saw also on the meeting there, Ethan joined us as our software engineer who helped us to build this app and integrate actually their system that right now it works. We can select the company, we can select the title and their customize the year's experience. The app will predict for you their base bonus and equity. So there is 3 components for prediction. Usually I like build the system when it's self-improving AI platform. So if I will leave that company, I want to make sure it works properly. It's self-improving. I can build another things, and this project and this company will still grow and it will work. So I build the feedback loop when we can submit and make edits into the compensation, and it will change the market. There is also 2 available links when you can review the app. Words is good, but again, let's do some demo and you can see it by yourself. The comp page. So it was the company for the flowers. Let's do their Google. And we would like, let's say, see their compensation for the director. In, I don't know, data science, maybe. Let's take the data science. We can move the years of experience to see the compensation for it. There is a package of how much the app predicts. But let's say you disagree with this number and you want to challenge it. When we challenge, let's say we are recruiters and we know more about it. So the base should be lower, the bonus should be more, the equity will be less. We submit it and the app celebrates. Right now, the market has changed. So all data that are submitted to the app will be using for their next time for their improvement. That's an amazing project, and I'm very proud to be part of it. And I'm glad that right now it's up and running. Right now, I will move to the last project where I'm a chief scientist. It's my 3rd app, Chronability. Chron from Greek means time, and ability, it's natural that we should have ability to do something. And the app is actually calculating the free available time, and you can customize, you can add tasks without mapping to particular time, because we know there is so much distraction around us. It synchronized all your calendars to integrate your full schedule. You can set your start and end time and see how much time left, how much you still have as your free time. And it's working the progress. And I was working part-time last year a little bit. Right now, after finish this course, when I'm teaching this spring, I will dive more into details. So I have a lot of different threads, and I would like to build the self-improving AI system to manage and suggest a healthy style of living that can be integrated. This app is right now, with current version, is available in Apple Store and the link of the website. What I plan is we plan to submit the application in August for NSF. Words is good. The last demo, I would like to show you this app. And it will be very simple. There is not much, but it's just a starting point. So I finished the lecture. I can make this off. We're given the talk. It started, so we can do like pause. And we also can add a task to review, I don't know, homework of the student. We can set time, how much we would like to allocate to this. And then the time will be, so it's too much for it now. Right now it's showing me like minus 45 minutes. So I plan too much for this day if I would like to end up with end time 5 p.m. So probably the review, it will be too much. So this is an app that again will synchronize with all calendars. So there is a lot of data and there is a lot of freedom to do things for the better. That part was more related to research and industry experience. But other than that, through all this path, I started my bachelor degree in applied mathematics that through all this experience till the last year when I immigrated to the US, I was collecting the knowledge between their expertise in practical uses and teaching. As well, that together with my parents, we are both professors in mathematics and technologies, and over the 10 years, we developed a virtual teacher software. Using the virtual teacher enables one of their intensively their learning process and reduce the time needed for assessing the students' knowledge and improve the quality of students' performance. You can see that the learning process about 30% more than traditional teaching methods. This system was awarded by the Department of Education and Science, and we have the copywriting of the Minister of Education and Science of Ukraine. My point is to summarize that the research, the projects, and what we teach to students, they come all together as a blend, and these coding techniques, statistical science, the domain expertise, domain can be different. This is all data science together, where we can do something better for the future. And this drive me to next thing that I started in 2017 together with Professor Bruno Rubino, who is Vice Rector right now of International Affairs, University of L'Aquila, Italy. So I was teaching a lot of data science courses. I came to my dean and we decided to create this program. We started in 2017, as I said, and we had 4 branches work in mathematics and scientific computing, applied mathematics and data science, mathematical modeling for elastic structure. We plan it, it's still like a work in progress, but it's needed, and there is already developed a plan for it. Modeling and architecture of computational systems. It's more related to their computer science, but it's a blend. As I mentioned before, the very good data scientist, in order to grow that person, it needs a combination of different knowledge. We built this program, and it's working, it's up and running. Even if I'm here right now, I taught the other professors who is teaching right now these courses, and as always, even without me, it's up and running, it's working, students enrolling, students get an opportunity to learn, and they are able to get jobs everywhere around the world. My last slide and their summary, what I would like to mention is, yes, it's difficult to be the creator of mathematical models or any algorithm. It's transferring our ideas from the human speaking language into computer speaking language. And we should be very careful about the quality of numerical results and quality of the calculations, and be careful about the speed of calculations. My strategy is that any problem that for some reason might sound like not solvable, can have their own puzzle, and we can find a solution. So, and since there is no problem in the world like not solvable, we just need more time to work on it, to solve it. And the algorithms are designed to make our life easier. The problem is they are designed by us, and we all have the good expertise in something, it's better to keep it, and it's better to apply where we can and do what we can in that place, in that moment. Thank you so much for listening. If any of my topic of research were interesting to you, I added their email over here. You can email me and I will be glad to have a discussion. That's all from my side for now. If you have any question, please ask. I will be very glad to answer it.
I think we should first thank the speaker for an outstanding presentation. And I'll open up the floor for questions. And it appears you have reactions where people have given you a thumbs up and a clap. But also Richard, I believe, has a raised hand for a question. And I also have a question. So Richard, why don't you go first?
No, I just hit raised hand as opposed to clap.
Okay, well, I'll give you, Kateryna, I'll give you a thumbs up, but I'll also raise my hand. So there you go. So my question has to do, it's kind of a meta question. And maybe this is about, you know, this notion of data science, because I found your talk intriguing. The first part is kind of right up my alley. I mean, right up my alley in the sense that, I don't know if anybody had told you, but I do a lot of work also with fractals. And I have a potential patent on a fractal procedure to make the world's perfect antenna. I just have to get around to checking all the things with my patent attorney to see how well we could push this through. But I was really struck by the beautiful construction you used using Cantor sets and what we call the Menger gasket, the two-dimensional version. And I was thinking, you have a sense of these mathematical models and using the Cantor set construction because you have a sense of convergence. I thought you got down to level 13 of the Cantor set, if I saw your chart correctly. And that's impressive because that's pretty far. I mean, that's fairly deep in the construction. And I think the reason you didn't go any further is because you had a notion of convergence. Like your model of the signal and the actual signal, you were fairly close numerically, right? Am I correct?
That point when I stopped to see much improvement. So I reached there 10 in -8 accuracy that my goal was initially given. So if I would increase any further Cantor set, that's okay, and I could do it, especially with that mathematical hypersingular model, which allows it, at least on that time, was not a very huge computer to calculate, but
right.
it was good. So I stopped because there is that a tiny thread between do we need to have this to increase the accuracy or not? So that's possible to do it. For example, if there is a need to increase accuracy, let's say we will compute the ring or something, so we need tiny details, and to do a 10 in I don't know, 20, then we can move through there, and the method I did is absolutely allowed it for that.
Excellent. And that's what I do in my work in signal processing. Like I produce a mathematical model, but then when I do numerical models, I say they work to such and such a degree accuracy. And I point out that, yes, you can increase this if needed, but you pay the cost in computational complexity, so to speak.
Yeah, that's why exactly what I mentioned on the last slide. I mean, we should figure out where this tiny slip between the speed of calculation, between the accuracy
Yes.
and our needs. Yeah, so I'm looking forward to cooperation with you, and as we spoke before, to have this article and see how this works, and especially with that article, publish it in Kharkiv University.
Yeah.
I think we can make this progress together.
So my question then is, with your apps, one of the things that we don't have with the apps that we do have with the signal processing model, and even the medical engineering, you could kind of view that through a mechanical engineering lens and talk about testing and degree of accuracy. But with the social apps, there is really no notion of convergence. So is the point to get it working and then just gather the data and then see if there's some sort of pattern that things settle into? I mean, how do you judge that, oh, this is a really good app? Is it because tons of people use it, or is it doing something that's, I don't know, worthwhile? Like, how does one with these social apps judge their quality?
Very good question, and I'm very like it. It's often asked, and that's why I started. Maybe I'm too modern sometimes, I think, because when that first app, when I was hard to build, they actually started with this question: how we can build the app which will have 2 million users. Right now, we don't have any. And let's say using their SQL or any table, how you can manage this. So in that time, I skipped the current things that were on the market, and I jumped into their graph database, into graph theory, where we can move through the nodes and relationships quicker. So we can increase their amount of users, 10,000, millions, 10 millions, and the speed of the calculations between the nodes and the relationship does not affect. So the much more complexity I heard and I worked with, let's find the recommendation for someone else who worked in that store, who read that book. So the deeps of the graph and the relationship was not affecting at all the speed of the calculations. So come back to your question, how to compare. So always the comparison, yes, it's users. And if the users get the information quicker, immediately, and just right now, that was given by that technology that I was using, they become happier, they use the app. So the same I was introducing in Apollo Factor, in Hornability, and all the app where I use it. So in order to keep users, active users, I use their graph theory and the graph database and Neo4j. The measurement is in Apollo Factor, it's a feedback loop when we have recruiters who knows this market, and let's say I predicted something worse, so they exchange it. In a spool app, when there is a ball, so that's also available to say a report. For example, I just didn't show, but it's the left side of the, for example, the size was not correct or something. So they able also to give something back us, and the machine learning in that model was a hybrid. It was a machine learning together with Neo4j. So I don't know, I left that company kind of like long time. So then I worked on another, I don't know what is currently in use, but in that time it was a two sides. So combination of offline machine learning and updating in real time their graph.
So it's kind of boss.
Excellent.
May I also ask some questions?
Yes, of course.
Of course.
Kateryna, the apps are gorgeous. I especially appreciate the virtual tour of Kharkov. I passed Kharkov so many times, but shamefully have never made it past the railway station. I'd like, of course, to know what's inside these apps. Let me formulate two specific questions. You partially answered when you answered Steve's questions. The one with the bubbles representing stories. So the size of bubbles represents the liking, or the number of likes. What do the location and the closeness of bubbles represent, and what information do we gain from the picture of these bubbles? And on your next app, when you were predicting everyone's salaries, what is it based on some statistical model that leads to prediction? Does it use any objective data, or is it only users based? So users use the app and comment whether this seems too low or too high, and recruiters say that this estimate is too high, and then the app adjusted accordingly.
Okay. Yeah, I just make a few notes.
Yeah, thank you. So I'd like to know what information
yes.
we gain from the bubbles and what their mutual locations represent. And how do you make predictions of salaries?
Okay, so the first question regarding to the location, actually at the beginning it was very tricky question and very hard how we can make their precise location that bubbles does not interrupt, but we would like to allow user to move the bubbles. But also there is a very mindful thought behind it. So there is a followers, there is someone who you like it. And the reason we did is locate the center. So they're all bubbles, they are coming to the center, and the most synchronized person is someone who you at least subscribed, follow it. So it's your more narrow neighborhoods, and the others are, so it might look sometimes strange on the screen, because if you like it more, the bubble will be bigger. So the center will be more bigger one, the others will be more smaller one. But that was their strategy behind theirs. And we create some geometric calculations behind of not overlapping and moving, etc. So we does use a lot of geometric formulas behind it. That's regarding to the score. Regarding to the data, very famous question when we show where you get the data, So yes, there is a survey each year, but the survey sometimes it's often outdated. And I was interested to work on this app since the director, their CIO, he has more than probably 50 years experience in recruitment. So he has this domain knowledge that I don't have. So working in collaboration, what he thinks and what his trend or thoughts or like just really expertise he shared with me, and it helped me to build the customized algorithm when I took 17 years all collected data surveys and all this. So I do use the data, but it was from very diverse sources, and especially the pattern and why I asked for 1 year off from teaching. And thank you for university allowing me to do this, because it was really complicated task, and it was in my mind. I could not stop it. I mean, it's something that like there is some unsolvable task and you want to solve it. So 99% of diversity and sparsity level of the data, 99. The data quality is very poor, no reliable, and the director was just like with a headache how we can use this machine learning that the salary will be predicted by the good quality of the data. So first I thought, okay, if we have the wrong data, let's fix the data first. So I created this data consistency algorithm that first fixed the problem with current existing data. And then after this, based on already good quality of the data, then I put it into the machine learning, then I put it into the graph, and all this started to work. But in order to use this data, I exactly apply my skills where I worked with singularities. So it's all matched because when I saw 99% singularity of the matrix, when there is nothing to rely on, and I just finished like PhD and haven't worked with these integral singularities and equations. So my custom algorithm, when I applied, it was kind of like hybrid, and what helps to fix that problem. So we summarize the question. I use the past data, and I use the domain knowledge expertise of the director with whom I worked.
So your prediction, say, of a salary of director of data science is not plainly the average of all data science director salaries in your data. You mix it with experts' opinion and with something else. And you mentioned machine learning, so you have some training and testing data and the prediction whose accuracy you can estimate.
The accuracy, very tricky. We were relying on the investors because when we first predict and release their product, the accuracy were about 25% off from the recruiter's opinion, and the investor said, no, we will not invest. Go to the 10. We moved after 3 months. I improved the model. We were predicting within 10% of the accuracy. Some investors were good about it, but then no, let's do 5 or 3. So they always pushing me back to the more quality. So I ended up with 3 to 5% of accuracy between their prediction and what recruiters think about it. That's how we measure it.
Thank you.
You're welcome.
Fantastic. Are there any other questions for Kateryna? Dr. Nolan.
Hi, Kateryna. In the very beginning, I think your second page, you wrote down these intervals that had singularities in them. You had something like eta minus z to the first power in the denominator, or to the second power in the denominator. Do you know anything about when you have a non-integer power? Are there methods to deal with such singular integrals in those cases?
Well, for all singularities, I use the discrete method to allocate their singularity apart from it. So all the strategy were, as we have the structure, then we allocate their singularities and then apply kind of like quadratic formulas for it, for specific part where singularity exists, and the rest are regular quadratic formulas. So then
Quadrature formulas?
yes.
Okay.
I use the Chebyshev polynomial, first, second degree. Yeah, also, yeah, that's good.
Yeah, and you can use Fourier analysis fractional transforms to help deal with that, but good old harmonica analysis comes in handy.
Yeah. Any other questions?
Any other questions for our speaker? I think we should thank her for an outstanding presentation. So thank you.
Thank you so much.